This is a video lecture for Math 110 for Friday, April 17th. And the topic today is compound interest. I want to tell you guys that I'm going to follow a slightly different approach here in the sense that I'm going to do multiple videos for a single day, a couple parts for a video lecture for a given day, just because these videos are very large files and it takes a long time to upload them. So I'm going to divide things into parts. I'm also going to try to keep the videos a little bit shorter. I realize I've gotten a little bit lengthy. So this is part one of the video lecture for Friday, April 17th. The topic is compound interest. If you guys remember, we've been talking about sequences and series. And then we talked about a particular type of sequence, an arithmetic sequence. It turns out a simple interest investment is an arithmetic sequence. And then we talked about another type of sequence called a geometric sequence. And the compound interest investment turns out to be a geometric sequence. What is a compound interest investment? With a simple interest investment, you invest a certain fixed amount initially, and then you earn interest just on that initial amount called the principal. With the compound interest investment, you invest a certain amount initially, and then in your first year you earn interest in that initial amount. You reinvest that interest back into the account, and then in year two you earn interest not only on the original amount but on the interest earnings from year one. And then in year three you earn interest on not just the original amount but the interest earnings from year one and two. So you keep on reinvesting your interest earnings, and future interest is earned on both the principal and the previous interest. And this is a much better investment because it will grow much more quickly than a simple interest investment. In fact, this grows exponentially. So if you guys are going to invest in something, you want to have a compound interest investment. And the value will actually snowball over time drastically. Okay, what I want to do is go through, I created a table very similar to the simple interest table, and I want to consider again an investment where we have a principal P equal to $1,000, and we have an interest rate of 10%, which in decimal form is 0.10. So we're investing $1,000 at 10% interest rate. Let's go through this table and calculate what the value is of our account. In year zero, there's no interest earned, and there's no accumulated interest, and the value of our account is just $1,000. Okay. In year one, we're going to earn 10% interest on $1,000. So in year one, we get 0.10 times $1,000, okay, and this equals $100. So we earn $100 of interest in year one. Our accumulated interest is $100, and the value of our account is $1,100 after year one. Now, so far, this is exactly the same as a simple interest investment. So you might wonder, what's the difference? Well, the difference comes in year two. In year two, the amount of interest I earn is 10%, but I don't earn the 10% just on the initial 1,000. I earn it on the previous value, on the initial 1,000 plus the previous interest. So the interest I earn in year two is 0.10 times 1,100, okay? And if you guys plug this in your calculator, this comes out to 110. So I earn $110 in year two of interest. And then the accumulated interest is 100 plus 110. So my accumulated interest is $210, and the value of my account is $1,210 after year two. Now notice, with simple interest, the value was $1,200. So with a compound interest investment, I've earned an extra $10. That might not seem like a big deal, and it's not very much, just enough to buy a lunch at McDonald's, right? But it gets better with time. In year three, my interest earnings, I earn not on the initial amount, but on the value of the account from the previous year. So I earn 10% of $1,210, and this comes out to $121. I've earned $121 of interest in year three. I add that to 210, I get $331. Okay, and the value of my account after year three is $1,331. Okay, now I've earned an extra $31 as compared to simple interest investment, which was $1,300. And then in year four, I do 1.10 times the value from the previous year, 1331, and this gives me 133.1 in terms of interest. If I add all this together, I get 464.1 of total interest earnings in 4 years, and the value of my account is now $1,464.1. Okay. So see what's happening here? I'm earning interest not just on the principal, but on the previous year's interest as well. So I keep on earning interest on a greater and greater amount of money. And so I'm starting to snowball the value of this account. And in fact, after year 4, I've earned an extra $64 as compared to a simple interest investment. Now I'm going to wait to do year 50. What I want you guys to notice is if I list out the values, let's list out the values here, and let's look at this as a sequence. A1 is 1,000. A1 is 1,100, which is 1.1 times $1,000. That's A1. Okay. A2. I'm starting my sequence at 1,100, so A1 is the value after year 1. A2 is the value after year 2 is $1,200, which is 1.1 squared times $1,000, or it's 1.1 times 1,100, but 1,100 is 1.1 times 1,000. So this is 1.1 times 1,000. A3, see if you guys can guess what A3 is. A3 is 1,331. Which it turns out is 1.1 cubed times 1,000. Okay, let's do one more. A4 is 1464.1, which is 1.1 to the 4th power times $1,000. Okay, now what is this? This is actually just a geometric sequence, okay? Because to get the next term, what I do is I multiply the previous term by a fixed amount. So to get A2, I multiply the previous term A1 by 1.1. To get A3, I multiply the previous term 1210 by 1.1. 1210 by 1.1 to get 1331. In other words, I'm multiplying each term here by taking the previous term, multiplying by 1.1 to get the next term. This is just a geometric sequence where my common ratio R is 1.1. Okay, so my common ratio R is 1.1. So that's pretty cool. Now what I'm going to do is erase this, and we're going to give you guys the end all be all. Well, I'm going to give you a formula, a great formula for compound interest. Okay, what if I'm interested in year? Let's say I'm interested in some year N. So AN. What's the value of the account in the nth year? Not in a particular year, but in the nth year. Well, it turns out this formula gives us this. The value of the account is equal to $1,000 times 1.1 to the nth power. So if you're interested, say, in the value of the account in the 15th year, n would be 15. The value is 1,000 times 1.1 to the 15th power. Now let's zoom in this though. What is this $1,000? This $1,000 is simply your initial investment, which is the principal. And what is this 1.1? Well, 1.1, in other words, equals 1 plus 0.10. Okay, well, what is this 0.10? That's our interest rate, R. That's our interest rate, R. And then this N is the year. The year you're interested in. So this leads us to a formula where the value of my account, so for any compound interest account, the value of the account is AN equals the principal times 1 plus your interest rate raised to the N power. So this is a nice little formula. And this gives the value of any compound interest account where N is the year and P is the principal and R is the rate, and that gives you the value, and AN is the value of account in year N. Okay, so what's the moral of this? I wouldn't ask you guys to derive this in a test, but the moral is compound interest investment is a geometric sequence, and this is how we can calculate the value of the account after N years. It turns out, here's a shocking result. If we plug in N equals 50, so how much is the account worth in the 50th year? I'm just going to write this value over here. $117,391. This is amazing. After 50 years, this account is worth $117,391. Incredible. We started off with $1,000. We've actually multiplied our $1,000 by more than 117 times. Okay, this is the power of compound interest. If you had invested this in a simple interest investment, you would end up with only $6,000 after 50 years, which isn't too bad. But you would have started with 1,000, gotten 6,000. If you invest 1,000 in a compound interest account with an interest rate of 10%, you would have $117,391 at the end of 50 years, which is pretty amazing. Moral is use compound interest investments. Okay, this is part 1 of the video. I'm going to come back for part 2. We're going to do an example problem.